Good evening, friends. So we are here again with interview preparation session, and we already discussed data science basics, and we have already seen some statistics also. So let's go today to data science algorithms. So let us take some questions on data science algorithms. Okay. Yeah, so first question of the day is, what is linear regression? Friends, you can just post it in the YouTube chat. Okay, so linear regression is the shows us the linear relationship between the dependent and the independent variable. So it is a supervised learning algorithm, and which helps us to find the linear relationship between two variables, basically you can say. So one is the dependent variable and one is the independent variable. The output column, we call it as dependent, as it is dependent on the input columns, which are also known as independent variables. So we can also call this output as the predictor, sorry, output as the response or dependent variable, and predictor as the input or independent variable. So in linear regression, we try to understand how the dependent variable changes with respect to change in independent variables. And if the independent variable, if there is only one independent variable, we call it a simple linear regression. And if there are more than one independent variables, it is known as multiple linear regression. Okay, let's take the second question. What are the assumptions we take for linear regression? So what are the assumptions required for linear regression? Yeah, line number. Vivek, I didn't get what is the number. Okay, so but assumptions that are required is the relationship between independent. Yeah, okay, numerical output. Yeah, so regression always has a numerical output, correct? Yeah, so here assumptions we make is the independent variable and dependent variables, the relationship between them should be always linear for linear regression. If it is not linear, our model will not work. Okay, then there is another assumption we make. It is that the sample which is drawn from the population should be a representative of that population. So the sample should represent all the qualities present in the population. Then next assumption we make is all the observation should be independent of all other, means every independent variable should be independent of another variable. So all the inputs should be independent of each other. And the last assumption is all the independent variables should be normally distributed. So these are the basic assumptions that are required for linear regression. Okay. Okay, so let's take the next. What is logistic regression? Yeah, Paresh. Yeah, correct. They should have equal variances also. I missed that. Yeah, correct. Okay, friends. So tell me, what is logistic? Means what is logistic regression? Okay, so let me tell you. So logistic regression is also a supervised algorithm, supervised learning algorithm. So this comes under classification algorithm. So logistic regression, we can call it as a classification algorithm that can be used when the dependent variable is binary. So output should be binary in this case. Okay. Okay, let's take the next question related to logistic regression only. So next is why logistic regression is so popular. Why is it so popular? Okay, friends, let me tell you the answer. So logistic regression basically is a very simple and very efficient method to classify binary classification problems. So whenever we are having a binary classification problem, this is the best model and it achieves very good performance in case of when we have linearly separable classes. This logistic regression algorithm gives very good performance. So when we are having this linearly separable class problem, the best model to choose is this logistic regression. Okay, that is why it is so popular. Okay, let's take the next question. What are decision tree? Yeah, Omar, correct. Rule-based technique. Yeah, so we can say decision tree is a supervised learning algorithm. Yeah, it has a structure like a tree. So we start with one variable and just we divide upon that to get to the output. So here it can be used for both classification and regression. So the output also depends on which type of model it is. So for classification, we have a categorical value as the output, and for regression, we have numerical value. Yeah, so the structure is something like this. So we have a root node here. Then we have something like this, and we have branch node. And last we have leaf nodes. Okay, yeah, here. So this is the root. These are the branches, branch node. These are the leaf nodes. Okay, so yeah, so let's go to the next question. What is pruning in decision tree? So what is pruning in decision tree? Yeah, correct, Shalini. Yeah, so it solves our overfitting problems. Yeah, correct. Yeah, Anupama, you are also correct. We remove so that the decision tree is less complex. Yeah, correct. Yeah, so it is a process where we remove sections of a tree that we can say is not as necessary or are we can say redundant. Yeah, we have two processes for that, pre and post. Correct, Anupama? So pruning leads to smaller decision tree, which gives us better performance and gives us higher accuracy also if done correctly. Yeah. So higher accuracy and higher speed also. Yeah, correct, Shalini. Okay, so let's take the next one. What is entropy in decision tree? Yeah, so what is entropy in decision tree? Yeah, Uma, correct. Yeah, Anupama, correct. Yeah, correct. Shalini, correct. Yeah. So it is the measure of impurity. Yeah, Shubham, correct. Measure of impurity or randomness also we can say. So it tells us, yeah, Shalini, correct. So it tells us about how pure or impure the values are in the data set. Okay. Yeah, Shalini. Yeah, you're correct. So I should repeat what Shalini also just put in the chat. So it is also important. So entropy ranges from 0 to 1, where 0, if we are having the entropy value, it it tells us that the data set is homogeneous, and when it is 1, it says that it belongs to different classes and is equally divided among them. Okay. Okay, so next we have what is information gain. So what is information gain? Yeah, so this is also related to decision tree only. Yeah, Anupuriya, correct. Yeah, Shalini, correct. Yeah, so when we are building a decision tree, at each step we have to create a node. So for this node, we have to decide a feature which would be used to divide the data or split the data. So for selecting this feature, yeah, we use this information gain. So it is a measure of how much entropy is reduced when a particular feature is used to split the data. Yeah, correct, Uma. So whichever feature reduces the most entropy, yeah, correct, it has the highest information gain. Yeah, so whichever feature reduces the most entropy has the highest information gain, and that is used as the feature which is used to split the data. Okay. Yeah, so let's go to the next algorithm. Next is yeah, let's go to Ensemble. What is Ensemble Learning? Yeah, sure, correct. Yeah, friends. So coming to the next one. Next one is Ensemble Learning. So yeah, you can type in the chat. Yeah, improve the reliability of a model. Yeah, we do Ensemble for that. Correct, Uma? Okay, so let me tell you. So when we are building models using the data science and machine learning algorithms, our goal is to find the underlying trends that are in the data, and we also want a higher level of accuracy. But sometimes what happens, the data sets are very complex. Yeah, yeah, Pushpak, that is one of the algorithms, correct? Yeah, so whenever the data sets are very complex, it is very difficult for uh, one model to be able to grasp all the underlying trends in the data set. So in such a situation, what we do is we combine several individual models together to get those underlying data and underlying trends, and to improve our performance using all those models together. So this is what is called ensemble learning. Yeah, Shubham, correct. Okay, so in ensemble, we have some methods. Let's go through them one by one. So first is, what is, let's take bagging first. What is bagging? Yeah, Pushpak, I think you should know this, bagging. You have already written bootstrap aggregation. It is same as bagging. Yeah, Shalini, correct. Bagging is also known as bootstrap aggregation. Okay, yeah, Shalini, yeah, correct. So in this technique, we form what is known as bootstrap data first. So in this, what we do is we make multiple samples of equal sizes, or you can say like, yeah, n size. Let us compare, means consider. So we are creating multiple samples of the n size, And this bootstrap data is then used to train multiple models in parallel. Okay, so all the models are trained in parallel. So this makes the model more robust, we can say. And once all the models are trained, then we have to make a prediction. So predictions are made according to our problem statement. So if it is a case of regression, we take the average value as the result. And in case of classification, we take whichever value has the highest frequency. Yeah, Shubham, not necessarily. So we have other things also. Instead of decision tree also, we can use other models. Yeah, we can say, yeah, that is something similar to voting, which what we do in bagging. Yeah, so let's go to the next one. Yeah, so what is boosting? What is boosting? Yeah, correct, Shalini. Okay, sequential. Yeah, Pushpa, correct. Yeah, so here we are similar to uh, bootstrapping, aggregation, or bagging. Here also we create many models, multiple models, but instead of training parallelly like we did in bagging, we train here the model sequential. Okay, so we create multiple models and we sequentially train them. So individually, these are all weak models, but by combining these weak models iteratively, yeah, correct. Sorry. So yeah, there are two types of boosting. Correct. Yeah. So yeah, where were we? Okay, let me start from the first again. So we create multiple models here and we sequentially train them. So individually, we can say each model is a weak model, but when trained iteratively, one after another, the new models become stronger and stronger. Okay, so whatever patterns we learn from the previous good patterns, it comes automatically to the next model also. So all the important features, important trends, we can say, is extracted successfully. So it is, yeah, so it is also used for reducing bias in the model. Okay. Yeah, so let us go to the next question. Next model is stacking. What is stacking? Yeah, Shalini. Yeah, so just like bagging and boosting, it is also an ensemble technique. So here we are combining multiple models to get a better accuracy or performance, we can say. So in bagging and boosting, we could only combine weak models, and we could only use same means one algorithm in each of the models. So for bagging, if we used suppose logistic regression, so only logistic regression will be used. But for stacking we can combine weak models that use different learning algorithms. Okay, so bagging and boosting are called homogeneous learners because only one model can be used. But in stacking we can combine different learning algorithms. So that is why it is also called as heterogeneous learner. So stacking works by training multiple weak models or learners, then using them together by training another model. So we create first a meta model by training all the different weak models, and this meta model is used to make prediction based on the multiple outputs of the predictors. So we can use this meta model to as a data set to means, yeah. Yeah, Shubham, correct. Building multiple model and choosing the best one. Okay, so let's go to the next question related to this only ensemble. So next is, what is random forest? Sorry, friends. Yeah. So next question is, okay, let me tell you. I think the random forest also I missed. Yeah. So for random forest, yeah, yeah. So for random forest, we have multiple models. Multiple models basically are the decision trees. So we have multiple decision trees, and we take the final output of all these trees together, and we get the output for random forest. So it uses bagging technique and something called as feature randomness technique when building each individual tree, and it tries to create uncorrelated forest of trees. So every tree is uncorrelated with each other. Okay. So how do we make the prediction? So if it is a classification problem, we take the tree, we take the majority vote of all the outputs, and if it is a regression problem, we are just taking the average of all the values. Okay. So yeah, so next question is, why is random forest so popular? Okay, just let me just go ahead and answer this. Yeah, so random forest are so popular. So for the case when we are dealing with high dimensional data, okay. So when we are having high dimensional data, it is we can say faster and also more accurate than a means simple decision tree. Yeah, so it is faster because here we are just creating subsets of data and we are just working on it. Yeah, yeah, pushback. Yeah, correct. So time, we can say it is low for random forest than decision trees or other algorithms also. And also we get higher performance also, higher accuracy in this case. Yeah, so when dimensionality is very high, random forest is a very good algorithm to use, basically. Yeah, Shubham, can be used for both regression and classification, correct? Okay, let's take the next question. Which is better? Yeah, which is better? Random forest or multiple decision trees? So which is better? Ensemble learning or multiple, dealing with multiple models is basically the question. So this is not ensembled one. This is ensembled. Okay. Yeah. Shalini said random. Shubham also said random. Okay. Yeah, yeah, correct. So random forest is the better choice. Yeah, yeah, it is popular, but yeah, so it is having, it is more robust. Means it can train high dimensional data. Yeah, Pushpa, good one. So it is having yeah, high dimensional data. When we are having, it is more robust, it is more accurate, and it is lesser prone to overfitting. So when we are using random forest, overfitting problem is also solved. That is why it is far more better than multiple decision trees. Yeah, friends, so I think we can just stop here for today, and we can, yeah, continue this session tomorrow. Yeah, that's what. Thank you all and have a good day.